So I'm going to show you how to calculate limiting reactant and also excess reactant. We're going to do a couple of practice problems. So let's get started with this first one. We start with 30 grams of ammonium nitrate and 50 grams of sodium phosphate. How much sodium nitrate can be made? How much NaNO3 can be made? Which of the reactants is a limiting reactant, and how much of the other reactant is left over after the reaction is complete? Because if one is limiting you, that means there's going to be leftover of the other kind, okay? So what I'm going to start with is just writing down the molar masses of these, because we don't want to have to worry about that. You know how to do that. So the molar mass of NH4NO3 is 80.043 grams. The molar mass of sodium nitrate, NaNO3, which is our product, is 84.994. And the molar mass of our other reactant, Na3PO4, is 163.940. Now that that's out of the way, we can just get down to the stoich. Okay, so doing these limiting reactant problems requires us to do basically a stoichiometry problem 2 times. Okay, so we are starting with 30.0 grams of ammonium nitrate. So ammonium nitrate NH4NO3. And we want to figure out how much sodium nitrate can be made. Okay, so we're going to go from ammonium nitrate to sodium nitrate. Okay, so we're going to, follow our mole pathway there. So first we're going to get rid of grams. In 1 mole of ammonium nitrate, there are 80.043 grams of ammonium nitrate. And if we look for our mole ratio to switch over, it's a 3:3 ratio. So I'm not going to simplify it. I'm just going to leave it the way it is, but I'm not going to even type it into my calculator. Okay, so for every 3 moles of NH4NO3, I get 3 moles of NaNO3. And for every 1 mole of NaNO3, I get 84.994 grams of NaNO3. Perfectamundo. Okay, so we have 3 significant figures here. And everywhere else there's more sig figs, so we're going to round to 3. We're going to put this into our calculator, and we're going to get 31.9 grams based off of NH4NO3. Oh, well, 34, so from 31.9 grams of NaNO3. Okay, cool. All right, so now let's think about, let's consider how much we can get from our 50 grams of sodium phosphate that we start with. 50 grams of sodium phosphate. Okay, 50 grams of Na3PO4. Okay, we are going to set it up about the same way. So in 1 mole of Na3PO4, there are 163.940 grams of Na3PO4. Now we want to switch over. We have to go back to our equation for every 1 mole of Na3PO4, we get 3 moles of sodium nitrate. So for every 1 mole of Na3PO4, we get 3 moles of sodium nitrate. And for every 1 mole of sodium nitrate, we get 84.994 grams of sodium nitrate. Perfecto. Okay, 3 sig figs again. All right, we're putting this into our calculators. And we can get 77.8 grams of sodium nitrate from sodium phosphate. So since we get less from the ammonium nitrate, this is our limiting reactant. Oops, I wanted to highlight that. This is my limiting reactant. Okay, and this is actually how much I can make. Okay, so let's answer those questions up here. How much of NaNO3 can be made? We can make 31.9 grams. Which of the reactants is the limiting reactant? Well, that was our ammonium nitrate, NH4NO3. Okay, now I'm going to show you something a little new. So if ammonium nitrate was our limiting reactant, that means that sodium phosphate, whatever, it's yellow highlighted. This is our excess reactant, which means that at the end of this reaction, yeah, there's going to be 31.9 grams of sodium nitrate in the container. But there's also going to be some leftover of this sodium phosphate that didn't get reacted. All of this ammonium nitrate is going to be used up. Okay, because in the limiting reactant problem, remember, one thing is going to be used up. We're going to get a total amount of however much we can get of our product. But there is going to be leftover of our excess reactant. And I'm going to show you how to calculate that. Okay. So what we want to start with is the amount of our limiting reactant. So we're going to start our equation. We're basically going to go from the amount of NH4NO3, which is our limiting reactant, used. Then we're going to go to our amount of Na3PO4 used. Okay, so that's going to give us some amount. It's going to tell us how much of our original 50 grams is going to be used up. And from that, we can say our original amount given in the problem minus the amount used up is how much excess left over there is. Okay, so let's do some stoich. Okay, so we're going to start with the amount of our limiting reactant. Okay, so that's that 30 grams, 30.0 grams of NH4NO3. Okay, and if we're using 30 grams of NH4NO3, how many grams of sodium phosphate are reacting with it? Okay, so I'm going to get rid of grams. So I'm going to put 80.043 grams NH4NO3 here, 1 mole. Okay, and then I'm going to look at their mole ratio. Well, I went into the next page. There are 3 ammonium nitrates for every 1 sodium phosphate. So there are 3 NH4NO3 moles for every 1 mole of ammonium phosphate. Okay, now for every 1 mole of, I'm sorry, did I say ammonium phosphate? I meant sodium phosphate. For every 1 mole of sodium phosphate, remember this is how we're going to find out how many grams of sodium phosphate were actually used up. We have 163.940 grams of sodium phosphate. Should be Na3PO4. Na3PO4. Okay. So obviously grams cancels out. Moles cancels out. We're going to put in our mole ratio. Okay, what we're solving for here is how much sodium phosphate was used. So I'm going to write the word was used here because I don't want you guys to think this is your final answer. A lot of kids just use this and say this is how much is left over, and that's not true. That's how much was used. Okay, so when you put this in your calculator, you're going to find that 20.5 grams of Na3PO4 was used. But that's not what you're being asked here, okay? You're being asked how much of the other reactant is left over after your reaction is complete, okay? Well, we started with 50.0 grams of Na3PO4. Okay, and we used 20.5 grams. Okay, so all I have to do is take my original amount minus my used amount to figure out how much is left over, right? If Mrs. Berger walks into TJ Maxx with $100 and spends $99.83, she's going to have 17 cents left over, and that's usually a pretty usual statement at TJ Maxx. That's why I walk into TJ Maxx with a credit card as opposed to cash, because then it's limitless. All right, anyways, so my original amount is 50.0, and my used amount was 20.5. Look at that. We have 29.5 grams of Na3PO4 left over. That's a beautiful thing. So we're going to put that answer up here. So we have, that's our non-limiting reactant, and we have 29.5 grams left. All right, so check this out. So if I want to make a statement about this reaction, right? We start with we're going to take 30 grams of ammonium nitrate and 50 grams of sodium phosphate, okay? We are going to produce 31.9 grams of sodium nitrate, and then we're also going to have leftover sodium phosphate. We're going to have 29.5 grams of sodium phosphate left over in our reaction container. Okay? Okay. And that's my dog barking. Okay, we're going to do another example. Okay, so we have this reaction, calcium carbonate and iron phosphate reacting to be calcium phosphate and iron carbonate. Okay, so what's the maximum amount of calcium phosphate formed? Which of the reactants is the limiting reactant? And how much of the other reactant is left over after the reaction is complete? Okay. So we're starting with 100 grams of calcium carbonate. And we want to go to grams of calcium phosphate. We're also going to do 45 grams of iron 3-phosphate, 45 grams of FePO4, and we also have to go to grams of calcium phosphate, Ca3PO4 too. So one of these is going to be our limiting reactant, whichever one of these gives us the least amount. So let's get our molar masses going here, okay? The molar mass of calcium carbonate, so molar mass of CaCO3 is 100.09 grams. The molar mass of our other reactant, FePO4, is 150.817. And the molar mass of our product, which is calcium phosphate, Ca3PO42, is 310.18 grams. Okay, so now that we have those, we can solve this limiting reactant problem. So starting with 100 grams of CaCO3, we're going to go to grams of calcium phosphate. So we have to get rid of grams. The molar mass of that is pretty close to actually the amount we have, is 100.09 grams of calcium carbonate, or 1 mole of calcium carbonate. And let's see what our mole ratio is. For every 3 moles of calcium carbonate, we get 1 mole of calcium phosphate, Ca3PO42. Okay, and then now we want to figure out how many grams of calcium phosphate we can make. 1 mole of calcium phosphate, we get 310.18 grams of calcium phosphate, Ca3PO4 dose. Okay, so when you put that in your calculator and you round to 3 sig figs, as you should, you get 103 grams. Okay. Next, we're going to figure out how much we can make based on iron 3 phosphate. So we have 45 grams of FePO4. Okay, we're going to get rid of grams and get moles. So in 1 mole of iron 3 phosphate, FePO4, okay, there are 150.817 grams of FePO4. Okay, let's take a look at our mole ratio. So there are 2 moles of iron 3 phosphate for every 1 mole of calcium phosphate. Calcium carbonate, sorry. No, I said calcium phosphate. That's the right thing. For every 2 moles of FePO4, we get 1 mole of Ca3PO42. Okay, and again, this last step is going to be the same, 310.18 grams of Ca3PO42. Okay, and in 1 mole, Ca3PO42. Okadokers, and this number here, 45, has 2 sig figs, so the answer here is going to be to 2 sig figs, and drum roll please, 46 grams can be made. So iron 3 phosphate is our limiting reactant. This is our limiting reactant. Oh, let's change that. Let me erase this. It's our limiting reactant. And 46 grams is the actual amount that we can make. We can't make any more than that. Okay, so let's write those down where our answers are. The maximum amount is 46 grams. which of the reactants is a limiting reactant? Is FePO4. How much of the other reactant is left over? Well, our excess reactant, so let me put a little highlighter here. Boom. That's not a highlight. Burger. This is my excess reactant. So what we want to find out is how much out of that 100 grams that we started with is actually used up. And then subtract that from the 100 grams to figure out how much is left over. Okay, so let's do it. Let's get this bread, this calcium carbonate bread. All right. So we are going to start with, we're going to go from our amount of limiting reactant used and go to our amount of excess reactant used. Okay, so since iron 3 phosphate is our limiting reactant, we're going to start there. 45 grams FePO4. Okay, we're going to get rid of grams, and 1 mole of FePO4. There are 150.817 grams of FePO4. Okay, so now we're going to switch over from our limiting reactant to our non-limiting reactant. So we're going to switch over from iron 3 phosphate to calcium carbonate, and that is a 2 to 3 mole ratio. Okay, so for now, for every 2 moles, 2 moles of FePO4, okay, we use 3 moles of calcium carbonate. And for every 1 mole of calcium carbonate, it takes up 100.09 grams of calcium carbonate. So this again is going to tell us how much calcium carbonate is required to react with 45 grams of iron 3 phosphate. Okadokes. So we're going to do this math in our calculator. Drum roll, please. And we're going to get 45 grams of calcium carbonate were used. Okay, so let's look back at our original amount. Well, we started with 100 grams of calcium carbonate. So we're going to take our original amount of our ER, excess reactant, subtract the amount used, and that's going to tell us how much is left over. All right, well, we had 100 with a little dot after it. That means that that ones digit is significant, and we're going to subtract 45 from it. And 100 minus 45 is 55 grams of calcium carbonate are left over. Okay, so if you have this reaction, let's talk it out. If you mix 100 grams of calcium carbonate and 45 grams of iron 3 phosphate, you end up with 46 grams of calcium phosphate, and remaining also in your container is 55 grams of unused calcium carbonate. Okay, so this is how you determine the excess reactant. If you have any questions, please send an email. Have a great day. Go Bears.